In this homework 5.7, we're going to be looking at sets of numbers and how to use the discriminant. So we start out with making sure we know our sets of numbers. We should know all of the real ones from middle school, but I think some middle schools skip over some stuff, so let's make sure we're solid here. I'll do D as an example. The directions say for each set of numbers, give 2 examples of a number that is not in a smaller subset. So we're looking for 2 examples of rational numbers. And this goes back to what rational numbers are. Rational numbers are numbers that can be written as P over Q. This is a ratio, and that's where the name rational numbers comes from. And so an example of a rational number would be like 3/4, or we could put 0.75. These are both rational numbers. And we could also put something like -1/10. Great. These are rational numbers because they can be written as a ratio of 2 integers. Just as a side note, you could also have the number like 7. 7 is a rational number because it could be written as 7 over 1. However, we can't put that as our answer for this one because it said we couldn't use it if it could be a member of a smaller subset. And 7 is both an integer, a whole number, and a natural number. And so these are all smaller subsets, which means they're contained inside of rational numbers. All natural numbers are also rational numbers. All whole numbers are also rational numbers. All integers are also rational numbers. And so we wanted an example of rational numbers that wouldn't be one of these other ones. So these are not integers, whole numbers, or natural numbers, but they're still rational numbers. All right, let's do this one. It says state all the different types of numbers it belongs to. So, for instance, if I pick this one, well, we just talked about rational numbers. This is a rational number because it is a integer divided by another integer. That's what a rational number is. But we can also write it as a real number because all rational numbers are real numbers. It's not a natural number because it's not 0, it's not 1 through 1, 2, 3, 4, 5, 6, 7, 8, 9 or the counting numbers. It's not a whole number because it's not 0, 1, 2, 3, 4, 5, 6, 7. It's not integers because it's not a positive or negative whole number. It is a rational number. It's not an irrational number. It is a real number because all rational numbers are real numbers. It's not imaginary. There's no imaginary component. And all numbers are complex numbers. So this -1/4 fell into 3 different sets. It's a rational number, it's a real number, and it's a complex number. The discriminant. So the discriminant is the part of the quadratic formula that is inside of the square root. So the discriminant is this. It's b squared minus 4ac. And this asks us to find the value of the discriminant. I will do b. Finding the value of the discriminant, it needs to be in general form where if it's an equation, it's equal to 0. And so it's x squared minus 9x plus 8 equals 0. I needed to rewrite this first before I find the discriminant. And now I can do it. B squared minus 4ac. So it is -9 squared minus 4 times a is 1 here times c. So we get 81 minus 32, which is 49. Is that right? 49? Yeah. So there we go. Cool. That's all I asked for was the discriminant. This next one I'm not going to do for you, but I'll at least help you set it up. It says a is a constant, okay, so some number like 7 or whatever, and it has a discriminant of 124. What's the value of a? So I need to find out what value of a gives me a discriminant of 124. This is really easy to do if I just set up an equation. The discriminant has to be equal to 124. So let's set it up. The discriminant is b squared minus 4ac. So b squared minus 4 times a times c. And that needs to equal 124. And this is just an equation we can solve. So you should go ahead and solve that equation. On the back, we're using the discriminant. We're evaluating the discriminant. We're going to state how many zeros the quadratic function has, and then what type of numbers the zeros are, being as specific as possible. So let's see. Let's do 2 here. And it's already equal to 0, which is great. So I can do the discriminant, which is b squared. B is -1. So b squared minus 4 times A times C. That's 1 minus 40, which is negative 39. Okay, so the discriminant is negative 39, and that's going to tell us how many zeros it has. And the answer is that there are no real zeros, but there are 2 imaginary or complex zeros. So I'm okay if you say no real zeros, but the better answer is, this is a more of an Algebra 2 answer, is that there are going to be 2 zeros. They're just both going to be imaginary or complex. Either way is fine, the way of saying that. So 2 imaginary zeros, that's what's going on there. All right, here we go. We've got this parabola. I'm going to do number 3 here, and we're trying to look at it and state how many zeros, what type of number the zeros are, and based on that, what the discriminant would have had to be. So A, the number of zeros, well, there's only 1. It's where it intersects the x-axis. There's 1 0. And it is a real, in this case, rational 0. It's 1 real rational 0. Okay? And because there's 1 0, that tells us what the discriminant is. If there's only 1 0, it's because we were doing negative b plus or minus, and it has to give you the same answer both for the plus and the minus, and that only happens when the discriminant is 0. So the discriminant must be 0. 0, because otherwise we would get 2 solutions, either 2 real solutions or 2 imaginary solutions. So hopefully that gives you a start. There were a lot of notes that went with this homework today, and so if you missed any of the notes, like, you might want to go back and get those, because they're like, I only went through one case to make sure you understood what was going on here, but there was a lot more in the notes. Okay, hopefully that helped.